Welcome everyone to the Seamless Research Forum. My name is Helena Forstein and I am the coordinator of the forum. We are a research forum and platform for doctoral students that focus on sustainable development. And our members are PhD students from across Uppsala University, and we're kind of interdisciplinary, so everyone is welcome. And today we're super happy to have Bregje van Veelen here. She's from the Department of Earth Sciences at Uppsala University. And I will let you introduce yourself. I just want to mention the title of this talk, which is New Frontiers of Climate Governance, Imagining the Modern Timber City. Very excited to hear about that. So without further ado, I hand over to you. Thank you for being
here. Yes, thank you. Thanks very much for inviting me to talk to you today. It's nice to see some familiar and some new faces in my little Zoom boxes at the top of my screen. It's a shame, of course, that we didn't get to meet in person, especially since I only joined the university earlier this year. It would have been nice to have a chance to meet some more of you face to face, but so be it. Hopefully we can still have a good discussion online as well, and hopefully I'll have a chance, for those of you I haven't met yet, a chance to meet you in the years to come. So I'm going to try and share my screen, and let's see if I can get it to work. Can you, Helena, can you confirm, can you see the presentation or do you see the presenter's view?
We see the presentation.
Okay, brilliant, perfect. So what I'm going to be talking about today is a bit of research that I did before joining Uppsala University. As Helena said, I currently work in the Department of Earth Sciences here in Uppsala. But before joining the university here, I worked as a postdoc at Durham University in the UK, where I worked on an international research project called Reinvent. And the Reinvent project sort of sought to understand how we can decarbonize what we might call hard to decarbonize sectors of the economy. So of course, a lot of attention for sort of decarbonization and low carbon transitions has been focused on the energy sector traditionally. And what this project tried to do was to understand what decarbonization might look like in other sectors of the economy, ranging from steel to plastics to agriculture. And as part of that project, my colleague Sarah and I worked on trying to understand sort of what decarbonization might look like in the construction industry or in the built environment. So we focused on attempts to reduce emissions in the built environment, and particularly the replacement of high carbon materials with low carbon materials. Now, Sarah and I are both social scientists, so we don't necessarily come at this from an engineering perspective, for example, but we're much more interested in sort of how these attempts to decarbonize the built environment are governed. And in particular, we sort of try to understand this by focusing on this, what we call a sort of emergent imaginary, and I'll sort of get back to that term imaginary a bit more later on, but this emergent sort of imaginary of the plyscraper, as it's often referred to. So which puts this idea of sort of timber skyscrapers, which you can see on the screen there, at the heart of the vision for low carbon living in the future. But the use of timber for these purposes also raises important questions, I think, for a range of different disciplines. You know, engineers might wonder how strong timber is and how it can be utilized in high-rise buildings. Architects might focus on the aesthetics of timber. Those with forestry backgrounds might ask how the use of timber in buildings competes with the use of timber for other purposes. And as a single researcher, I won't be able to answer all those questions or to focus on all those dimensions. And as I said, as a social scientist, I am particularly interested in how timber has come to be sort of positioned as the material of choice, by whom, and what this might tell us about different ways of governing climate action. But I know this is an interdisciplinary group, so I do encourage you to think about how some of the themes or the topic of this talk might resonate with your own area of research, and hopefully we'll have a chance to discuss some of that after I have finished talking. So without further ado, let me get started. And I think where we were coming from in this research project is sort of, as I said at the start, is that I think the focus of climate action and decarbonization is starting to shift. Historically, or in the last few decades, a lot of focus of sort of decarbonization attempts, as well as research, has been focused on the energy sector. You know, how can we shift from fossil fuels to renewable energy? But really, carbon is embedded in pretty much every aspect of our lives. And that was the starting point for our research. Sort of where or what are the different sites where carbon is embedded, and where does this, or what does this mean in terms of decarbonization or shifting to a low carbon society? And I think slowly but surely, sort of buildings are becoming increasingly recognized as an important site of climate action. And again, perhaps in the last few decades, that's been largely been in terms of energy use in buildings and how we can reduce that, and I'll come back to that. But slowly but surely, I think there is a recognition that we shouldn't just focus on sort of how buildings are used and the implications for climate change, but also how buildings are built and the implications for climate change. And this sort of growing focus on buildings overlaps as well with the growing focus on the roles that cities might play in combating climate change. Because of course the world is becoming increasingly urbanized, which also means that an increasing amount of our emissions emerge from urban areas, whether that's in terms of work environment, transport, living, or all those dimensions. And what we are seeing is that cities do slowly but surely play a leading role in tackling climate change as well, especially in places where sometimes national level climate action is lacking. So for example, we see initiatives such as something called the C40, which is a network of international cities committed to tackling climate change, setting their own targets for low carbon transitions, or sort of achieving a net zero society, for example. So as I'm saying, so slowly we see these sort of new sites of climate action, and we see that both in terms at the city level, as well as at the level of buildings. And that was one of the reasons why we became interested in sort of this role that buildings can play in decarbonizing society and the economy. And buildings do, or have an important role to play here, because the data is not entirely, or there's not always a lot of agreement between different data sources in terms of emissions from buildings, but broadly we can say with some confidence that about 20 to 40% of all emissions come from the built environment. So that is quite a substantial proportion of all the carbon emissions that we emit. And sort of recognizing this role that buildings play in emitting carbon, but also the role that they can play in tackling these emissions, has resulted in an emergence of sort of initiatives that try to tackle emissions from the built environment. At the moment, about 90 or just over 90 countries have committed to tackling emissions from buildings as part of their national contributions. And it is expected that this will only grow sort of in the near future. But to date, the majority of efforts to tackle these emissions from buildings have focused largely on what we call operational emissions. So these are the emissions that are associated with the use of a building, so primarily heating and electricity. And you'll likely be familiar with some of the efforts to tackle operational emissions. They might range from energy efficient light bulbs to improved insulation to lights that automatically switch off when you leave the room, better glazing in housing to keep the heat in. All those things, all those sort of mechanisms are trying to tackle these operational emissions from buildings. But notably, I think over the last decades, discussions of climate governance in cities and the built environment have seen a rising concern for what we call embodied carbon or embodied emissions. And these embodied emissions are the emissions that result from building construction, maintenance, and demolishment. So this also includes the emissions, or this largely includes the emissions that are sort of locked into building materials. So the emissions that result from producing particular building materials. And this is where the quote on your screen comes into it. Bill de Blasio is the mayor of New York City. And he gave a speech last year saying that we're going to make it clear that the kind of glass and steel buildings of the past, and some were built and are being built still, are not going to be allowed anymore in the future. And it's true, if you think of any major city skyline, you're most likely thinking of tall, shiny glass and steel buildings. And these buildings are often built with a foundation of steel or concrete and an outer layer of steel and glass. But these are some of the most high carbon building materials that exist. So as de Blasio indicates there, it's time to start looking at lower carbon building materials if we're serious about tackling climate change in the built environment. And the reason why tackling these embodied emissions is important is visible in the image on your right-hand side of the screen there. That's some data that's from the UK, and it might vary a bit from country to country. But as you can see from the image there, in 2012, so almost a decade ago, almost 80% of carbon emissions from buildings came from the use of buildings, so operational carbon, so your heating, your lighting, etc. And only 22% was embodied carbon. So you might say that's not a huge proportion. But in recent years, we've actually become quite good at tackling operational carbon emissions. There's still a lot to be done, but we are making progress there. So what that means is that it's expected that over the years or decades to come, the total emissions from buildings might decrease, but the proportion of these emissions that are made up of embodied carbon are expected to grow. So basically, we're reducing operational carbon, but we're not reducing embodied carbon quite as much yet. So that is one of the reasons why different stakeholders operating in this area are starting to push to tackle this embodied carbon, because that, especially in the near to medium term future, that will be a growing proportion of all emissions that come from the built environment. But tackling embodied emissions is difficult, to say the least, for a number of different reasons. I don't know how clear the image or the figure sort of in the middle or at the top of your screen is, but that sort of shows the life cycle almost of a building. And as you might be able to see, operational emissions really only emerge from one part of that life cycle. Basically, when the building's up and running and people are using it, that's where operational emissions are emitted. On the other hand, if we want to tackle embodied emissions, we have to think about all these different stages of the life of a building where embodied emissions are emitted into the atmosphere. This ranges from the extraction of raw materials to transportation, to construction, to demolishment, to landfill. So there are lots of different stages to think about if we want to tackle these emissions. So that makes it a difficult coordination problem. And that raises the question, who should tackle these embodied emissions? Who should be responsible for tackling them? And how do we get the different actors involved in these different stages to sort of sign up for this, or to play their part in this? So that was partly, or at least one of the questions that Sarah and I focused on. It's like, if we want to tackle these emissions, and it is a difficult sort of coordination problem, how can we do that? And what I want to do next is, first of all, give a bit more of an introduction or a bit of background in sort of governing climate action. Because in the end, this coordination problem is a question of climate governance, I would say. So I'm just going to give a bit of a background into sort of how we might think about climate governance, because I know there's a lot of people from different disciplinary backgrounds here, before returning to the example of timber and plyscrapers, and how we might understand what is happening there through a lens of climate governance. So what is climate governance? What do we mean when we talk about climate governance? And I would say, probably if you ask 100 social scientists to give you a definition of climate governance, you'll probably get 100 different definitions. But to me, at least in short, climate governance is looking deeply into the how of how do we steer and shape change in the climate sphere. Climate governance is, I would say, deeply multi-scalar. So it's not just a question of national governments taking action, but it involves actors from individuals, from the individual or the household level all the way up to the international level. It's multi-actor. So again, it can involve individuals, public sector, private sector, third sector actors, who make up sort of the sphere or the implementation of climate action. And climate governance is not just about regulation, and I'll come back to this. But in the end, climate governance is implemented or enacted through different infrastructures, because different infrastructures shape the way in which we live our lives in society, and the way in which we emit carbon or don't emit carbon. So it's important to think about these infrastructures as sort of enacting or enabling particular ways of low carbon or high carbon living, working, thinking, and doing. So, as I said, to me, at least, climate governance is not just about regulation. It's not just about the rules, the laws we put in place, but ultimately, climate governance, I would say, is a project of reimagination. It's about thinking about the world that we want to have, or that we need to have in the future. And ultimately, this is about sort of developing, or this process of reimagination is about developing a new sort of collective understanding of what the world should be like in the future. And that requires us to think about not just the technologies that we want, but also the kinds of social and economic systems that we want or need to have in the future to have a low carbon society. And while the sort of process of reimagination, or the academic literature that uses this sort of lens of reimagination often focuses on sort of the social dimensions and sort of how we might envision societies of the future, this literature on sort of reimagination and imaginaries often also foregrounds technological projects. So it asks what kinds of technologies and how they're employed would enable the kind of society that we want to achieve. So that is sort of the conceptual sort of setting in which Sarah and I have placed this work, by basically arguing we need to look not just at the rules or the regulations that are in place, but sort of what kind of society is envisioned, and what role do new technologies or infrastructures play in that, in enabling that type of society. And the reason why we focus on plyscrapers or on sort of this particular object as a lens through which to understand attempts to tackle climate or to tackle carbon emissions in the built environment is because these kinds of technological objects, especially high profile ones, such as these timber skyscrapers, play an important role in sort of making an imaginary concrete. It allows us to think about not only what does such an object look like, but what does, how would society operate if we had more of these objects, and what kinds of society and actions and activities would these objects enable. So we focus on this object of the plyscraper in our research because it's becoming in a very visible way, I think, of sort of shaping discussions about tackling emissions in the built environment. It's something that really speaks to the imagination of a wide group of stakeholders, and it sort of has the ability to transcend boundaries between different disciplines, but also between sort of researchers and academics and everyday citizens. Because the reason why we decided, or how we became interested in this sort of this object of these timber skyscrapers, is because it seemed to be picked up a lot in everyday media. You know, slowly in the last few years, we suddenly saw articles popping up on the BBC, you know, popular magazines like GQ magazine, Elle magazine, other lifestyle magazines, as well as more trade-specific press, all talking about these timber skyscrapers and, you know, what they could mean for sort of the city of the future. So for us, that offered a really interesting opportunity to try and understand what role these skyscrapers might play in shaping society of the future. How do they imagine, or how do they represent this imagination of the city of the future? And I think a few key components of this sort of skyscraper or plyscraper imaginary are important to mention here. Is that, again, it very much it doesn't assign a big role for government, for example, in tackling emissions. Instead, it very much focuses on the role of cities and industry itself as being able to lead on efforts to tackle climate change. But it's also very much a project of material replacement as a solution. So, and I'll come back to this a bit later in terms of, you know, the kind of society that it represents or envisions. Is it really that different from the society we have now, or is it just a case of replacing high carbon with low carbon materials? So basically, just to sort of sum up sort of why we decided to focus on this is, one, I think it's a very increasingly sort of visible imaginary through which proponents of a low carbon future try to represent that low carbon future. It's becoming increasingly popular in different sectors of society, or there's a growing interest in it. But I think just having this imaginary of a sort of timber skyscraper of the future, just having that imaginary alone in and of itself is not enough, of course, because this is great that you can, you know, you have these fancy drawings of sort of or architectural renderings of timber skyscrapers, but how is this imaginary turned into reality? Through what mechanisms is it being translated into reality? Like, how are people actually trying to implement this? And that question of sort of implementation and the mechanisms through which this imaginary is translated into reality was what we wanted to focus on in our research. Now, before exploring these mechanisms through which the imaginary is realized, let me explain a little bit more about the technology behind these plyscrapers. The key technology is what we might call mass timber, and especially cross-laminated timber, which is the type of mass timber. It's sometimes also referred to as engineered wood, or CLT, which is the abbreviation for cross-laminated timber. And it basically works, as you can see on the drawing that's on your screen there, in terms of it's basically beams of wood which are pressed together into big slabs of wood. So you basically end up with these huge slabs of wood, which can be quite, I think, up to 10, if not more, meters long and wide, basically, which can be used to construct the structure of buildings. So it's not just, you know, as you might have here in Sweden as well, on sort of the outside of buildings, but it's very much a structural building material. So you can build a building frame from this type of wood, which is a bit of a game changer, because historically wood is often associated with single family homes. You know, look around in Sweden, you've got your red wooden homes all across the country. But this kind of engineered timber allows for building much higher structures because they can carry much more weight. So basically they enable the building of multi-story skyscrapers out of wood. And this kind of engineered wood was first used in Central Europe already back in the 1990s, but it's only been in recent years that it's sort of catching on in different parts of the world. And it's now much more geographically diverse, with sort of CLT being used in various countries in Europe, but also North America, Australia, New Zealand, Japan, for example. So not only is this kind of wood strong, but because of the way in which it's constructed and the way in which it's treated, it's also fire resistant. So one of the main things you always hear when building high buildings out of wood is, how safe is it? According to proponents, you know, CLT does go through all the normal fire resistance test and is as safe, if not safer, than other building materials. And there's a few different reasons why it's sort of growing in popularity. And this is a mix, because of a mix of both sort of push factors, which are basically the forestry sector in recent decades has often not been doing that well in a lot of regions, as timber has been going out of fashion in some ways. So there's a big push from both forestry companies as well as regions or countries that are highly reliant on forestry industry to push the use of timber in buildings. So for example, the Swedish government, or I think Swedish forestry, is quite a big proponent and also funds different initiatives around the world for building with wood, because they see that as a good potential opportunity for market growth. So there's a push for the use of timber in building from sort of forestry companies and rural as well as national economies that are highly reliant on forestry. But there's also some pull factors, particularly a growing demand for low carbon building materials, which comes mostly from urban areas, building developers, city politicians and others who want to tackle these emissions in the built environment. So there's sort of a number of different reasons sort of why the case for timber is increasingly being made. But that has at least led one person, whose quote is there on the screen, to proclaim that engineered timber will define 21st century architecture. Whether that will become true, I think, remains to be seen. But I think it is indicative of this push for timber that's happening in various countries around the globe. So timber as a building material is growing in popularity, but how did this happen? And as I said, there are some push and pull factors, but that doesn't necessarily explain how timber managed to overcome the sort of coordination problem of getting all these actors on the same page and actually implementing and starting to implement this sort of vision for a timber future. So our main focus in this research project was trying to understand how did sort of timber become presented, or not just presented. So basically timber has been presented as the natural material of choice for building 21st century urban buildings. But how is that actually being realized? How is that actually being implemented on the ground? Because that's great that it's being positioned in such a way, but you need so many different actors sort of signing up to this, from architects to developers, to construction companies, to forestry companies, to demolition companies, urban politicians, rural politicians, and so on. So to get all these actors sort of agreeing to this and being like, yes, okay, let's do this, is a whole other step, basically. And that's what we sought to understand in this research, sort of how is this actually being implemented and being realized. And we distinguish two distinct approaches which exist in parallel at the moment to sort of governing this process of making timber the material of choice. And one is what we might call a calculative form of governance, which focuses on very much on sort of making visible and quantifying emissions to enable comparison and benchmarking between timber and other kinds of building materials. And basically this calculative approach is very much focused on trying to show why timber is necessary. But then we also identified a second approach, which is very different, and is what we might call an effective or aesthetic form of governance. And that's not focused so much on sort of quantifying emissions or showing why timber is necessary if we want to tackle climate change. Instead, this aesthetic approach is very much focused on making timber desirable. So, you know, let's leave out all the difficult carbon calculations, but let's try and focus on making timber a desirable product for people to have. And I'll go into more detail to explain these two approaches next. But basically, what we sort of argue is that these are two very different approaches to positioning timber as the material of the future. And each of these approaches has both positive as well as potentially unintended consequences that we need to understand if we're thinking about low carbon transitions and what the implications of these transitions might be. So methodologically, basically we use a range of different methods or qualitative methods to try and understand these emerging governance approaches, ranging from going to industry conferences and workshops to interviewing people, as well as reviewing a lot of academic and grey literature, a lot of reading of trade magazines, architectural magazines, etc., to try and understand how timber is increasingly positioned as the material of choice. So just to summarize this first part before I go into more detail of the two distinct governance approaches that we identified. So just as a quick summary or a reminder, in this project, we consider climate governance not just to be about regulation, but about reimaginations, requiring us to ask what kind of world do we want. This emergent imaginary of the plyscraper and at the heart of this sort of low carbon city of the future offers what we might call a materialized answer. So it offers an imaginary of an urban low carbon future with natural materials at its heart. But just having such an imaginary is not enough, and we need to ask, how is this imaginary being made concrete? How is it turned into reality? And that's why we focus on these two different governance approaches that I will explain. But before I go any further, just wanted a quick check if there were any questions so far. Just sort of quick clarifying questions, and then we can leave more in-depth questions for the end. No? Okay, then I am just going to move on. I might take a quick just sip of water. But, okay, Just checking. Yeah. So how is this process of making timber the material of choice? How does that happen? And as I said, we distinguish two distinct approaches to climate governance. But ultimately, both these approaches, I think, what they try to do is sort of pin down, as we might say, timber's material qualities. So that by that we mean, how are the particular aspects of timber, because you can think of timber in a lot of different ways, and I'll get to that in different ways. So how are these qualities or aspects made visible, and how are they made necessary or desirable? So why do actors feel like they have to sign up to this or have to get involved with this? And to date, we still often see the case for timber being made on the basis that it is supposedly inherently low carbon. You know, we have quotes here from the literature that says, you know, it seems to make sense to use timber. Wood sequesters carbon, while concrete and steel are made by burning fossil fuels. Interest in building with mass timber structural products such as CLT has skyrocketed, in part because of the presumed lower embodied carbon impact. And sort of reviewing both the trade literature as well as popular or news articles about the use of timber in buildings, you'll see a lot of this in terms of, oh, timber, of course it's low carbon because it's natural. And on that basis, I think that has enabled timber to gain some popularity as a building material. But increasingly, such generic sort of claims are not sufficient, or people view those claims with growing skepticism. And it is increasingly important that construction companies, building developers, etc., can demonstrate in more detail that the materials they use are actually low carbon, and not just that they say that they are low carbon. So instead, to really make the case for timber and make sure that it's put at the heart of the future of the low carbon city, proponents of timber, as well as academic researchers, have increasingly tried to quantify those truth claims that, you know, that timber is inherently low carbon. And that is what we see as a form of calculative governance. And by that, I mean the production of usually sort of numerical or statistical data in order to define a problem and enabling it to be governed. And such quantification helps to indicate that a piece of infrastructure or a particular material is important and needs to be implemented. And that is partly what I did at the start of this lecture, you know, by framing climate action in cities as a necessity because of you know, buildings contributing 20 to 40% of emissions. That's a very calculative way of thinking about this in terms of, okay, we have a percentage of emissions and we need to bring that down to a certain level. And while we might have become accustomed to thinking about climate governance in this sense, it isn't necessarily the only way to tackle climate change or to think about what's important or where to focus our attention. But this sort of calculative approach is becoming very dominant in climate governance, and it's reflected in the quote that's there on your screen that says, if you can't measure it, you can't manage it. And that is extremely indicative of this calculative approach, saying that you need to be able to measure it in order to be able to tackle it. But also it sort of, while it doesn't say it, it almost implies that the opposite rings true as well, that things that you can't measure aren't worth focusing on. So this calculative approach is very much focused on being able to calculate emissions and using those calculations to identify a problem and to identify potential solutions. And this approach to tackling climate change is increasingly prevalent in the built environment. There's a growing industry that specifically focuses on measuring and tackling embodied carbon. And you know, there's actors involved in this ranging from a lot of academic researchers in engineering and other science-related disciplines, as well as sustainability consultants, for example, but also to some extent forestry companies themselves, sometimes construction companies. They're all trying to sort of get increasingly detailed data on the emissions that emerge or that are associated with the built environment, and often with particular materials used in the built environment as well. But quantifying these emissions is incredibly complex. And that's why it remains quite a specialist activity. And there are a number of different ways in which these calculations are being undertaken, or in which these calculations are being done. Some are very much at a material level. So there's something called an environmental product declaration, which is becoming increasingly important, where producers try to ascertain the emissions of a particular product. So you might just have like a steel beam, for example, like a 2-meter steel beam, and a producer will need to be able to calculate what the emissions are that are embedded in that steel beam, so resultant from its production. But increasingly, just having the emissions of one particular product is not enough. What we're increasingly moving towards is what's called a whole building life cycle analysis. So that focuses not just on the emissions that result from a particular product, but really what are the emissions of a building across its entire life cycle, so from production to demolishment. And such life cycle analysis are basically a way to make carbon in buildings and the construction supply chain visible. And this whole building life cycle analysis should more accurately allow for carbon comparison between different construction techniques, as well as using different materials, for example. So in many ways that sounds great, because that's, you know, we increase our knowledge of sort of the emissions that emerge from buildings and what high carbon options are versus what low carbon options are. But while the numbers that come out of this, as well as the analysis that's being done, are increasingly complex and therefore might give the impression that they're increasingly accurate, there is a lot of continued uncertainty about what to include and what to exclude in these types of analysis. And that leads to a variety of problems, which are not necessarily specific to timber, but to life cycle analysis more generally, in terms of where do you draw the boundaries of your analysis? You know, if we are talking about, say, a building built out of timber, do you include the forestry practices into that, or do you only start counting after the trees have been harvested? Do you take, you know, the end of life into account? You should in a whole building analysis, but not everyone does. So there's a lot of different ways of conducting such an analysis, which can lead to wildly different outcomes. And this is to some extent, I would say, problematic, because these types of analysis increasingly inform what we might call governance devices. So new standards, forms of certification, as well as regulation, which try to tackle emissions in buildings, and which increasingly request the use of life cycle analysis to demonstrate whether a building is high carbon or low carbon. But while there's continued uncertainty about these life cycle analysis and what to include and what to exclude, it becomes very difficult to use that as an input for them trying to govern emissions, basically. So there are problems with life cycle analysis in general, but that's even more so the case when we start to think about timber, and I will get to that in a minute, to the more timber specific issues around sort of trying to push timber as a low carbon material through calculations. But before getting to that, I think just a general word about whether such a calculative approach is effective in reducing emissions from what we can see so far. And the short answer is not really, because even though these calculations are becoming increasingly advanced and complex, at the moment, people don't always really know what to do with these calculations. As I said, slowly we're starting to see sort of standards and regulation emerge, but there's not much of that yet. At the moment, these kinds of calculations are primarily used in what we call voluntary certification schemes. A big one in the UK and other parts of Europe is BREEAM. In the US, LEED is a big one. And these are certifications that developers can apply for to demonstrate that their building is green, basically. But such certification schemes are largely voluntary at the moment. And the choice of materials only plays a really small part in it. So when Sarah and I set off on this research project, one of our aims was to understand, are these types of voluntary certification schemes that include the calculation of embodied emissions, are they driving change? Are they encouraging developers to choose other materials? And the short answer is not really, because these certifications are just voluntary, and the choice of materials doesn't actually play a big part in whether your building is certified as green or not. So on the one hand, we're seeing this growing complexity of these calculations, but then at the moment, at least, people don't really know what to do with them yet. And I think that might change in the near future. We are seeing more regulation being brought in that will use some of these calculations to say, perhaps you can only build buildings that have a certain amount or that are below a certain threshold of emissions. But that's not really the case yet. So at the moment, we're seeing this development of increasing calculations, but then nothing is really done with these calculations. But some might argue that perhaps that is only for the best, for now at least, because these calculations are not, as I said, as accurate as you might think that they are. There was a lot, as I said, of early enthusiasm for wood as being, of course, a green building materials, as of course being a green building material. But as these life cycle analyses are becoming more advanced and more complex, these analyses are also showing that actually, is timber always, or they raise the question, is timber always the greener option? And that is very difficult to say at the moment, because these types of calculations are increasingly sophisticated, but the outcomes are still often inconsistent. And I think that is especially the case when it comes to timber, because there are so many different variables involved. It's about how to conduct a calculation. Where do you draw the boundaries? What data sources do you use? If you think about the use of timber in construction, you have to take into account the tree species, where it was grown, how it was harvested, what kind of soil has it grown on, what happens after it's harvested, how much of the tree is used, what's the rest of the wood used for, etc., etc. So there's so many different variables involved here that it becomes very difficult to do an accurate analysis, and not just to do an accurate analysis, but also one that others can then use and mimic and compare themselves to. So at the moment, there's lots of different people doing these kinds of analysis, but they all make very different methodological choices. And these different methodological choices can affect the result by a factor of 10 or more. So while you might see some of these analyses saying, yes, timber is definitely the low carbon material of choice, and it's much better than using steel or concrete in buildings, if you conduct the same analysis but make a few different methodological choices, you might actually end up with an outcome where timber and steel might have quite similar emissions. So there's an issue here in terms of sort of doing these calculations, both in terms of the choices that are made while doing the calculations, but also the particular difficulty of timber itself. And we say that timber is unruly in that sense. It's very difficult to standardize these measurements or these calculations for timber, because there are so many different variables involved, as I said, in terms of tree species, where they're grown, harvest practices, etc. So that makes it very difficult to have a standardized set of data to use for these types of calculations. So while these calculations may portray an image of sort of objectivity, the reality is not that simple. So as I said, so just to sort of briefly summarize, what we see, or what I argue, is this calculative mode, or these types of calculations are a partial but not yet very successful attempt to implement change. They're trying, they're an attempt to try and encourage the uptake of timber by showing it to be a low carbon material versus other materials that you could choose. But because of the uncertainty around the calculations, there is only a limited uptake so far, and partly that is to do with the uncertainties that are still there in a lot of governments, as well as standard organizations that implement standards don't yet want to include these calculations if they can't be sure that the calculations are accurate, comparable, replicable. So that sort of limits the uptake of timber in that sense, because the calculations aren't entirely clear yet, or aren't entirely solid yet. So while we're getting better at doing these calculations, as I said, there's still not a great deal of actual uptake or sort of implementation, because no one really knows what to do with these calculations at the moment. So that sort of hampers the uptake or the implementation of timber as a building material, because people want to choose it if it's lower carbon, but if they can't be sure that it's lower carbon, then there's perhaps no point in using it. But that is one of the issues. But the other limitation, I think, of this sort of calculative mode of governance is when we zoom out. So, it's great that we can hopefully do these calculations in an increasingly accurate way for ever smaller pieces of material. But I would raise the question, do you also, risk sort of narrowing our vision and losing track of the bigger question of how our built environment is used and by whom and who it should be for? Instead, it reduces sort of decision-making around climate action simply to, the emission of a steel beam or a timber slab, without asking these bigger questions of what and who our built environment is for. So I think this sort of calculative mode of governance sort of risks a narrowing of vision. And this narrowing is partly what the second mode of governance, which I'll move on to, seeks to address. So basically, as I said, so we have one sort of mode of climate governance, which is very much a calculative mode focused on sort of getting ever increasingly accurate calculations, but there's not a lot of uptake of those calculations yet. But at the same time, Sarah and I, when doing this research, we did observe change happening in terms of these timber skyscrapers increasingly covered by regular media, increasingly being built in various cities around the world. I mean, you only need to, it's perhaps not the highest skyscraper, but you only need to cycle around Roosendaal here in Uppsala to see a growing number of timber buildings popping up all over the place. So, we were like, okay, so we do see these timber towers sort of popping up, but at the same time, we found from our research and speaking to people that this change is not driven by calculations of emissions. Then what is driving it? And we found, or we argued, that the change that we do observe is perhaps largely driven by the promotion of a particular aesthetic of the built environment that does seem to be able to align different actors. And we suggest that this aesthetic mode of governance, as we call it, and I'll explain it in a bit more detail, is doing real work in realizing this low carbon imaginary of the plyscraper, and basically implementing a sort of broader vision of what low carbon urban living in the 21st century could look like. And what's sort of made visible in this aesthetic vision is not the detailed numbers of carbon emissions or these quantifiable numbers, but rather timber's aesthetic aspects or its aesthetic qualities. So we say that this is a project of what we call aesthetic visioneering. And it's not sort of complex or technocratic as life cycle analysis and difficult softwares, but instead it's very much taking place through glossy architectural renderings, site plans, etc., which try to promote timber as a desirable material to build with. And in that sense, it's not just about this narrowing of vision of the emissions of a particular timber slab, but instead associating timber with an alternative possible urban world that looks desirable. So where the calculative vision relies on complex technical work performed by engineers, sustainability consultants, academics, central to this aesthetic vision are instead very prominent architects, as well as urban politicians, which see the use of timber as a way of not only having a sort of green city, but also a desirable modern city of the future. So in this sense, this sort of aesthetic vision is not about, timber's, carbon parts per million, but instead positioning it as enabling a desirable lifestyle. It positions timber as enabling an urban future, one that emphasizes, urbanness, but also naturalness, enabling connectedness to nature, healthy living, various sort of key terms that you can see in bold on your screen there. So it positions timber as part of a lifestyle where you can escape the stress of everyday modern life while still living an urban life. So it's very much focused on sort of the aesthetics of what timber looks like, but also the affective dimensions. And by affective dimensions, I mean sort of the sensory dimensions. So what timber feels like, what it looks like, what it smells like, and positioning that as a potential desirable trait. And this focus on, you might say, timber, oh yeah, healthy living, peacefulness, etc. Really, I mean, I think it's good to be slightly skeptical of those claims. But this focus on those sensory qualities is not entirely far-fetched, because there is some evidence to suggest that people have positive responses to wood and use of timber in buildings, although there are a lot of questions around the universality of those findings. But in essence, this sort of aesthetic vision argues that the employment of natural materials can create a sense of connection to nature, which supposedly can benefit people's own health as well as the broader environment. So in this sense, this sort of mode of governance doesn't necessarily position the environmental benefit of timber as an end to itself, but rather it argues that the use of timber can enhance the well-being of those who use, who live or work in buildings. So it's perhaps a slightly more selfish way of arguing that, this is not just good for the environment, but it's good for you as an individual using these buildings. You will feel more relaxed or more productive in these environments. So to some extent, it's a selfish argument, but through this sort of positioning of timber as a desirable material, it positions it not only as desirable for those who use it, but also for the city as a whole. It's saying that timber can make cities as a whole sort of greener, more pleasant living environments. And it does so often by positioning, as you can see in the image there, these new kinds of timber buildings in already existing or yet to be built sort of green environments to really emphasize, the environmental or well-being qualities of these types of designs. But of course, this is a process of simplification as well. It often doesn't take into account people who might already be living in or near these spaces, some of the urban inequalities that might exist in these cities. And instead it very much focuses just on this picturesque sort of urban nature connection. But as I was starting to say, this idea of making over cities as forests, as a forestry company says it themselves, also has important social consequences, because it's all nice and well to position these sort of, desirable timber buildings at the heart of a desirable form of urban living. But these buildings will be built in already existing cities with already existing inequalities, social issues, economic issues, etc. So the image on your screen there is from Google's sidewalk project, which they were going to build in Toronto. But what they found in Toronto was that there was ultimately so much opposition against that project because people who were worried, who were already living in Toronto and who were worried about the increasing unaffordability of the city, the increasing gentrification taking place, that ultimately Google Sidewalk pulled out of the project. And I think that sort of struggle, which I don't have much time to go into more detail about, really indicates that it's all nice and well to have this aesthetic vision of a desirable city of the future, but that doesn't negate some of the very complex processes that are already going on in our cities and that these new kinds of buildings will have to negotiate. So just to wrap up, because I am running out of time, is what I've tried to show is that what we are seeing in these attempts to implement the increased use of timber in our built environment. There's two very different approaches to trying to implement this. One is very calculative, focusing on really trying to demonstrate that timber is lower in carbon than other building materials, but with a lot of difficulty. Whereas the other one's very much focused on the aesthetics of timber and making it seem nice and desirable, and trying to get it to be implemented in that sense. So not just arguing timber is necessary for the climate, but timber is what we want for our cities and what you should want for yourself. But both of these approaches really obscure some really difficult complexities in terms of timber, and particularly its environmental dimensions, which is very much overlooked in both approaches, or I think not fully incorporated or recognized, but also obscures some of the complexities of the cities in which these buildings are going to be built, and how these buildings might interact with the already existing social and economic processes in place in these cities. So just to sum up sort of the final messages, what I've tried to show in the last hour is that I think it's worth thinking about climate governance, not just as a process of regulation, but as one of reimagination, and sort of asking, what world do we want to see in the future and how can we get there? But while we can have such sort of imaginaries or visions of the future, they need to be materialized in particular ways. And one such way is here through the construction of new buildings made out of different materials. And this process of materialization, so trying to get different actors on board and building these kinds of buildings, can be done in different ways. In this case, it's being done through calculative approaches, but as well as through aesthetic approaches. And these two approaches exist sort of side by side at the moment. And I wouldn't say that one is very dominant. In the future, one might become more dominant, but at the moment, they're still both sort of trying to become the approach of choice. But what sort of governance approach we choose also shapes the forms of social, economic, and environmental processes that we change, but also what stays in place and what are we trying to change and what will stay the same in the future. And I would almost argue that while I think climate governance should be a process of reimagination, I think this particular example is both an example of reimagination, of sort of envisioning a type of urban future, but to some extent it's perhaps also a failure of imagination, that it's in the sense that it imagines a new type of building material, but it doesn't necessarily have much to say about the wider social, economic, and environmental sort of processes or world that these buildings will be built in. So I will leave it at that, and I'll ask Helena to sort of say what we will do next. A short break first, I think.
Yes, yes. And can you all see me? No, you cannot see me, right?
I've stopped sharing. So.
Okay, now you can see me. Thanks a lot. That was super interesting. I took a lot of notes, and I guess others did too. So now let's take 5 minutes breaks, and then we return and start a discussion, and we can have all our questions ready. And recording will stop now. So thank you for everyone who's listened through YouTube.